We have already mentioned the use of acids in the main milling system. This acid will now, together with the substances being digested, move on to the next units. This represents a very grave danger to the digestive system, because these units, the duodenum for example, have no special protective layer, such as that in the stomach. So how is it that the duodenum is not harmed by these acids? When the level of acids reaching the duodenum with food from the stomach reaches a dangerous height, a hormone known as secretin starts to be released by the cells in the intestinal wall. There are several points regarding this process that need to be considered. First, the hormone secretin that protects the duodenum exits in the cells on the surface of the intestine in the form of prosecretin. Under the acidic effect of digested food, this hormone turns into another chemical substance, secretin, and this hormone eliminates the harmful effect of the secretions. Second, the hormone secretin arrives at the pancreas by the way of the bloodstream and instructs the pancreas to release enzymes. Aware that the duodenum is under threat, the pancreas sends bicarbonate molecules to that region. These molecules neutralize the gastric acid and protect the duodenum. The way that cells in the dark depths of the human body, which have no eyes or ears, no brain, and no consciousness, operate within such a flawless order is a result of Allah's sublime creation. It is Allah, the Omniscient, who creates the cells and the properties they possess. Allah shows us the infinite nature of His might, in features such as these that He has created in the human body. The digestion of everything we eat is completed in the small intestine. The final stage of digestion, however, is the absorption of digestive products for distribution to where they are required in the body. Very little absorption takes place in the mouth and stomach, which are also components of the digestive system. Absorption takes place entirely in the intestines, and the structure of the small intestine is fully suited to this process. The interior surface of the small intestine is highly corrugated and contains microscopic pumps. These pumps are absorbent cells which trap the nutrients needed by the body and pump them to the blood vessels to which they are connected. Thanks to the corrugated surface of the intestines and the micropumps in it, the small intestine has a very large surface area. So large, in fact, that it can reach up to 300 square meters in adults. This is the approximate equivalent of 2 tennis courts. Digestion of nutrients takes place in this large area. Food is first broken down and turned into a kind of paste. This is then spread over the inner surface of the intestine in such a way as to cover it entirely in a very thin coating. The cells are thus easily able to extract all the nutrients from the food. One special function of the small intestine is that it absorbs as much of certain substances as the body needs. For example, too much iron is harmful to the body. Excess iron above a particular level that reaches the intestines is expelled from it without being absorbed. In addition, the small intestine has a very special area consisting of cells that only absorb vitamin B12. Unless people who have had this section of the intestine surgically removed receive the appropriate medical treatments, death is inevitable. Some nutrients are absorbed in the large intestine. One of these is vitamin K. This is an important vitamin that serves in blood clotting, and a deficiency of this vitamin can have very serious consequences that can even lead to death. However, in nature, vitamin K is not found in the form needed by the human body. The body has to turn this vitamin into a form in which it can be used. In other words, it has to refine it. So, how is it that people do not die of vitamin K deficiency? What is the mechanism that refines this vitamin and turns it into a form that we can use? Special bacteria in the intestines subject vitamin K to a series of processes, refine it, and make it capable of being used. The vitamin K, refined by these bacteria, enters the bloodstream by being absorbed to the large intestine. The way that we need such tiny bacteria, the presence of which we are unaware of, and whose name we may never have even heard before, is a matter calling for considerable reflection. No coincidence can give rise to a bacterium, place that bacterium in the human intestine, and then make its genetic material capable of performing processes useful to human beings.